This lesson continues Thevenin equivalence, but now the circuit contains both an independent source and a dependent source. That changes the way we find R Thevenin. We cannot simply turn everything off and combine resistors, because the dependent source must stay active. The network has a 20-volt source, a 100 ohm resistor with current IB, a dependent current source equal to 9 IB, and a 10 ohm branch at terminals A and B. First, find the open circuit voltage V Thevenin. Let the terminal voltage be V Thevenin from A to B. The current IB through the 100 ohm resistor is 20 minus V Thevenin divided by 100. KCL at the top node gives V Thevenin minus 20 over 100 plus V Thevenin over 10 minus 9 IB equals 0. Substituting IB and simplifying gives 20 V Thevenin equals 200, so V Thevenin is 10 volts. The first resistance method is the short circuit current method. We keep the independent 20-volt source alive and short terminals A and B. The short forces the terminal voltage to 0, so the 10 ohm branch has no voltage across it. The 100 ohm resistor now carries IB equal to 20 over 100, which is 0.2 ampere. The dependent source injects 9 times that current, or 1.8 amperes, upward into the top node. The current through the short is the sum of the current coming through the 100 ohm resistor and the current injected by the dependent source. That is 0.2 plus 1.8 equal to 2 amperes. Therefore, R Thevenin is V Thevenin divided by the short circuit current. 10 volts divided by 2 amperes gives 5 ohms. The Thevenin equivalent is a 10-volt source in series with 5 ohms. The second method is the 1 amp test current method. This time, we turn off the independent 20-volt source, so it becomes a short circuit. Then we connect a 1 amp current source from B to A and call the resulting terminal voltage Vx. Now IB is 0 minus Vx over 100, so IB equals negative Vx over 100. KCL gives Vx over 100 plus Vx over 10 minus 9 IB minus 1 equals 0. Substitute IB equals negative Vx over 100 into the test source equation. The dependent source term becomes plus 9Vx over 100, so the total is 20Vx over 100 equals 1. Therefore, Vx is 5 volts. Since the test current is 1 ampere, R Thevenin equals Vx over 1 ampere, which is again 5 ohms. The Norton current is V Thevenin over R Thevenin, equal to 10 over 5, or 2 amperes. The main lesson is this. Independent sources may be turned off when using a test source, but dependent sources stay active. For this circuit, both valid approaches agree. The open circuit terminal voltage is 10 volts. The short circuit current is 2 amperes, and the 1 amp test source gives Vx equal to 5 volts. So the final result is R Thevenin equal to 5 ohms, with a 10-volt Thevenin source, or equivalently a 2 amp Norton source. One last way to remember the rule. Independent sources are physical sources whose value is fixed from outside the circuit. When we use a test source method, a voltage source with 0 volts becomes a wire, and a current source with 0 amps becomes an open circuit. A dependent source is different. Its value is controlled by another circuit variable, like IB in this example. So it must remain in the circuit, and the controlling variable must be written into the equations.